Let's now take the beautiful circle and put it on the coordinate plane and actually start to locate important features about it. For example, its center, its radius, and start looking at graphs. All right, well, first of all, the equation of a circle that's centered at the point h comma k and has a radius of r can be expressed in the following formula. X minus h all squared plus the quantity y minus k squared equals r squared. So the important thing here to realize is that the x value for the center appears here, and notice it's x minus the x value center, and then the y value center, k, appears here as y minus that value, and then we have r squared. This really is coming from the Pythagorean theorem, which of course is a recurring theme in all of mathematics. Here's a question I want us to consider. Let's write the equation of the circle A that's centered at A, which is negative 1, 5, and has radius 4. Well, not too hard to do. You follow the template, and we say, okay, x minus negative 1 all squared plus y minus 5 all squared equals 4 squared. And we could simplify this a little bit because a negative times a negative is a positive. So x plus 1 squared plus y minus 5 squared equals 25. There's the equation. What does it look like, by the way? What does a circle look like? We can actually graph it. Let's see if we're doing okay. What? 4 squared, 16. Come on. Please. 4 squared. 5, if it were 5, then 25 is a good answer. But 4 squared, you know, is 16. All right, let's graph it. So if we graph it, well, the center is going to be at negative 1, comma 5, so there's the dot, and now we have to draw the circle that has radius 4. So that means that from this point I have to go out 4 units, 1, 2, 3, 4, so that's a point on the circle. I can go 4 units this way, 1, 2, 3, 4, that's a point on the circle, 1, 2, 3, 4. These are easy points, sort of north, south, east, and west of me. I could go out 4 units this way, but of course the grid doesn't really show me how I should behave. Now I've actually got the challenge of trying to draw it in. When you get good, you can actually draw not a bad circle. What do you think? I don't think it's that bad. Anyway, centered here, and the radius is 4. And this is the equation. Neat. Let's try another one together. So let's write the equation for circle B that passes through the point negative 2, 3, and has a center 2, 0. So I think the thing to do here is just to try to graph it first and see if we can get a sense of what's going on here. So the center is at 2, 0. So the center of this thing is at 2, 0. So it's right there. So that's the point B. And that represents the center of this. And I don't know the radius, but I know that it passes through negative 2, 3. Way up here. So that's a point on the circle. So how am I going to figure out the radius? Well, we can actually find the distance between these 2 points, which you notice would actually give me the radius, because that's the center and this is 1 point on the circle. So we can use the distance formula, which is equivalent to looking at the Pythagorean theorem. What's this part of this right triangle? 1, 2, 3, 4. So this is 4. 1, 2, 3, 3. This is a 3, 4. This is a very special right triangle. It's a 3, 4, 5. So in fact, I happen to know that this is 5. Or you can check that 3 squared plus 4 squared will equal 5 squared. Anyway, the radius is 5. And so, how can I write down the equation for this circle? Well, I know its center. So I have x minus 2 squared plus y minus 0 squared, notice the center, 2, 0, equals the radius squared. Oh, 5 squared. I know what that is. That's 25. And so I can write this nicely as x minus 2 squared plus just y squared equals 25. So there's the equation. And you can see that we're starting off And you can try to graph it, but I think it's going to be a little tricky. 1, 2, 3, 4, 5. Points out there. 1, 2, 3, 4, 5. There's a point there. 1, 2, 3, 4, 5. Point here. 1, 2, 3, 4, 5. Point here. And if you connect all those points nicely and quickly, you get a sense of what the circle looks like. Not bad, not bad. There you go. Anyway, you can now see how to represent a circle not only visually, but now algebraically.